Welcome back to another set of flipped classroom videos. So today we will be looking at similar triangles, and specifically we are looking at our side similarity theorem. Last video we looked at our angle similarity theorem. So today we're looking at our sides. Just like with our congruency statements, 3 sides can also tell us if 2 figures are similar. So if I have all 3 pairs of corresponding sides of 2 triangles being proportional, then they are also similar, okay? But they do need to be proportional. So in order for me to check for side similarity, I first have to identify my corresponding sides. Okay. Once I know my corresponding sides, I can write my side lengths as proportions. Okay. And then I'm going to either simplify or compare my ratios. Okay. Remember, a proportion is a ratio. If all my ratios are the same, then the triangles are similar. And we're going to look at a couple examples below to see if we have proportional sides making our triangle similar. So number 1, I don't have a similarity statement, but I can use what I know about my side lengths to determine which sides should be proportional. Because triangle DES is actually upside down and flipped from triangle KNR. So I'm going to start with my longest 2 side lengths. I have KR segment, right? And SD segment being the longest 2. So I'm going to write that out as 20 and 25 hundredths over 31 and 5 tenths as my first ratio. I'm then going to go to my smallest sides, and I'm going to go ahead and write those out. So I'm going to write 9 over 14 for my next set of ratios. So I have 9/14, which leaves 13 and 5 tenths over 21. So I'm going to simplify all of my ratios and see if I get my same ratio. So 9/14, okay, 9 is divisible by 3 and only 3, but 14 is not divisible by 3, making this my simplest form. Okay. I have 20 and 25 hundredths over 31 and 5 tenths. And I can divide both of these by 5. So I have, which means my top ratio becomes 4.05. And my bottom becomes 6.3. Just looking here, I'm going to erase that highlighting. I'm going to change the color. just looking at these two ratios here, they're not the same, which is going to tell me that these two triangles are not similar. Okay. I don't even need to go to my third triangle to determine this information. Okay. Triangle number 2 looks like it's only one triangle with a midsegment, but really it's 2, and we can go ahead and split our triangles up. What I mean by that is I'm going to remove triangle WXV from the top and look at triangle WUY. It's just one big triangle. So this segment length right here is actually 28. WY is really 21. And UY is still 42. Okay. But now I can take what I know about WX, which is 15, WV is 20, and now I see two triangles and not just one. So I can go ahead and start writing my ratios. So I have 15 over 21, 20 over 28, and 30 over 42. So now I'm going to go ahead and start simplifying. Well, 15 and 21 can both be simplified by 3. So that becomes 5/7. 20 and 28 are both divisible by 4, which 4 goes into 25 times, and 4 goes into 28 7 times. So already I have 2 ratios that are the same. But because I need all 3 sides to be the same ratio, I still have to check number 3. I can't stop there. So 30 and 42 are both divisible by 6. So 6 goes into 35 times, and 6 goes into 42 7 times. So now I have 3 ratios that are similar, making triangles WUY similar to triangle WXV. Okay, so that is similar to triangle WYU. All right. So you have 2 examples of triangles, one that's not similar due to my side similarity, and one that is. Please write down any questions you still have. Make sure you have at least one about our flipped classroom notes, and have a great afternoon.